Hello, and welcome to the second networking lecture, Connecting to a Network. In this lecture, we're going to identify the different roles and different network devices that are used both on a local and network and how they interact with internet and get us connected onto the World Wide Web. We're going to look at the advantages and disadvantages of different types of connections, and we're going to look at how to connect a computer to a wired or a wireless network, and some of the basic wireless access point settings that we can use to secure a wireless network. Let's begin by looking at internet service types and some of the hardware that is going to be needed to make these connections. We're going to look at switches, access points, and routers and modems. A switch, let's start with a switch. That's going to be on the local area network, and it's going to connect multiple computers or devices together through a wired connection. As we looked at the previous lecture, it's going to make the data traverse the switch using MAC addresses to identify which computer is connected to each port. The router slash modem is the device that is going to connect the local area network to the wide area network, which is going to be the internet. So routers always interconnect to different networks. And most of the SOHO or small office home office have one device that performs the router function and the modem function or gateway that is provided by the ISP. And the gateway is just what it sounds like, the gateway to the internet. It's commonly referred to a modem, but technically that's not what it is currently. And lastly, we have an access point. And that is the part of the network or the device on the network that provides Wi-Fi connectivity. It's going to have antennas, and it allows all our wireless connections, connected devices to work with our local area network. Now, frequently, you're going to find all of these devices in one. So that device you get from your ISP really contains all of these devices in one box. You could have all of these as separate devices as well if you wanted to. So broadband internet is going to come in a couple of different flavors or possibilities. We have the DSL, which comes from your phone company and is using the copper-based telephone cabling to carry the internet signal. It's currently using ADSL as a technology, and the connection coming into your house is going to look like a telephone wire and use an RJ11 port, which then will connect to your gateway. Let's talk about cable next. Cable is very similar to digital subscriber line, and it's using the cable that was originally designed for cable TV to carry the internet service into your house. So it uses the same cable for your cable TV and for your internet. And it uses a specification called DOCSIS, and I think we're on DOCSIS 3 point something at the moment. And lastly, what we're all after is fiber optic to the home, and we have a couple of different ways that could get here. We could have fiber coming all the way to the house, so the fiber end of the fiber cable is at our house, or fiber to the curb, where then there's another copper wire run from the curb into our house. So how do we verify if we have a connection? Well, on Windows 10, you have to be able to look at the network icon, and it's going to be in the notification area. And this first symbol is a good connection. This one means no connection. And when you have the little yellow triangle, that means you have a connection to the local area network, but no connection to the World Wide Web. And one of the easiest ways to check to see if you can get out to the World Wide Web is just simply to browse to a website that you know is working. Typically, google.com works quite well for that. If we're in an area that doesn't have DSL, coaxial, or fiber, we may need to use a microwave satellite to get our broadband internet. In that case, you're going to have a fairly large, I think they're about 18 inches or so, dish that points at the satellite, and you can send and receive information or data across that. The problem is that because the satellite and the satellite dish are so far apart, you have high latency, which means it takes a long time between, in computer terms, a long time for when you send a request and before it comes back. For many things, it really doesn't matter. For browsing websites, I mean, it's a little bit annoying, but when you start doing video conferencing and trying to play games with this, it doesn't work out very well. The other thing that many remote areas do is we can use cellular radio to get our internet service. So many cellular services sell these little hotspots, which will allow us to contact a cell tower and use that for our internet service. These can be good. In some remote areas, our cellular radio coverage is a little bit better than our broadband, DSL, and cable coverage. So it's possible that this will work better. If you have good cellular service on your phone, you're going to have good cellular service for your data. And they use several different types of services: GPRS, HSPA, CDMA, LTE, and LTE Advanced. And of course, the new one coming up is 5G. So radio frequency is just our Wi-Fi networking. I think I would throw Bluetooth into this category as well. So we can do Wi-Fi networking at our home, so we set up our own. If we go outside our home, you'll find something called open or public access points, like at your restaurants and other businesses that you're allowed to use as a customer for free. So there are some wireless standards. They are set up and maintained by the IEEE, and they all start with 802.11, and then they have a letter after them: ABG, NAC. N and AC are the current standards that you're going to be using. So you have to make sure you have an access point that is compatible with the Wi-Fi on the devices you're using. So if you have older devices, they may not support N or AC, and you might have to go back to B or G, for example. The great thing about access points is they can support a wide variety or different mix of devices on them, and they really don't mind that much. The Wi-Fi treats your gaming console the same as your cell phone, the same as a computer. On the left here, you'll see there is the A, B, G, N, and AC standards with the transfer rate and the band that they use. Good idea, especially if you're going further into IT, is you're really going to need to memorize these standards because they show up all the time and are frequently test questions. So how do we set up an access point? The first thing we have to do is figure out how do we get into the configuration of our access point. If it's the device that we got from our ISP, likely the instructions on how to get into it are going to be on the bottom of it, along with the username and password. If you bought something, commercial product, it's going to be in the directions. But the first thing you always want to do is locate that. It's likely that you're going to use your browser and navigate to an IP address that's given, so maybe 192.168.1.1. And once you get in here, the first thing you want to do is change the password. There's been so many security vulnerabilities from that not happening. It should be automatic. I get a new device, I put it on the network. The next thing I want to do is change the password. And then I'm going to set up the settings. I'm going to determine what IEEE standard I'm going to use, so maybe N. I'm going to set a service set identifier, so the name of my wireless network. And then I'm going to set up the WPA security on it, along with a passphrase for access to my wireless network. So we want to use wireless security. It's going to give us encryption so that nobody can read what we're sending back and forth. We've got several different standards, WEP, WPA, and WPA2. WEP is really no security. It's easy to be broken. WPA is also possible to be broken. At a minimum, you should be using WPA2, and WPA3 is just around the corner and will be out shortly. So when we're using those, we're going to have a pre-shared key that we can share with whoever we want to have access. It's frequently referred to as a passphrase instead of a password. So when we're out there and we're going to our favorite business and we want to use their Wi-Fi, there's a couple of things to know, and one is open authentication. So if you join a network and it says it's open, it means there's no encryption, so everyone can read what you send back and forth between your device and that open wireless access point. And we also have something called a captive portal. You may have seen that, where you log into the Wi-Fi network, and the first thing it asks you is to agree to some terms. And when you do that, the business is just trying to protect itself in case you do something you shouldn't on their network. So you're agreeing to be a good person while you use their access point. Secondly, like places at a hotel or is a common place, they might also, in conjunction with the captive portal, they might actually put in like your last name and hotel room to make sure that you're allowed to have access to that wireless network. Even though it's open and everyone can see it, they might still have a secondary type of authentication to allow you to use it. So on our computer, if we're going to configure our wireless side to it, here we're looking at wireless or Windows 10. You can see that when you click on the wireless symbol here, it'll show you a list of possible Wi-Fi networks. You can choose one and click on Connect. If you're going to use it all the time, you want to use the Connect automatically. And the next thing it's going to ask you for is the passphrase. If you know the passphrase, you're going to get in and it's going to remember it. The other thing that you can check is, just like we showed at the few slides ago, is you want to look at your network connection button, and even if you're connected to Wi-Fi, it is possible not to have an internet connection. So you need to make sure that you connect to the Wi-Fi and that you actually have an internet connection, and then you're ready to go. So Wi-Fi has some limitations, including range. They say up to about 30 meters indoor, and that's going to vary based on what your walls and how many obstacles are in there. And the farther away you get from the base station, the signal attenuates or it gets lower, so your speed slows up. Your access point is going to use something called DRS, which reduces the data rate as the signal gets further away. It's focusing on a reliable connection over speed. So there's a lot of materials that'll block your Wi-Fi signal. Notably, concrete and metal are the worst, and there's all kinds of other sources that interfere with it, such as microwave ovens, fluorescent lights, electromagnetic motors. So if you have a trouble with the connection between two rooms, you're going to want to perhaps move your wireless access point around a little bit until you get a good connection. Now, if we're using a wire to access our network, we're just going to use likely a standard twisted pair cable with RJ45 jack. If we're at a business, we likely have it in the wall. If not, we might have a port on the back of our gateway provided from our ISP. Or at a business, we might have a enterprise grade switch, as you see here in the picture. And we can connect switches to switches if we have a lot of computers. So this one is probably 48 ports, but if we had more than that, we might add just a second switch next to it and connect the two together. So we can have literally thousands of ports on a local area network if need be. Now, when we come to an enterprise network for Wi-Fi, we're going to use the same Wi-Fi standards. It's going to implement a few other authentication protocols. So not only do you have to know what the network name is, but before you can get on the network, you're going to sign in with your username and password for the company before you have access. So when we say enterprise network access, we're really adding some authentication in there for the network. Our enterprise network routers are also going to be larger devices than you see at your house, and they give us the ability to connect multiple what we're going to call VLANs. So if we have a business and we have multiple networks on our local area network, which is common because we like to separate things, especially the Internet of Things from, say, our computers. But a VLAN means that we're using one cable and we have multiple networks running on one physical cable. Virtual LAN, that's what it means. But even if I have one physical cable and I have multiple networks on it, the only way that those devices on multiple networks can communicate is it still has to go through a single router. Even if it's using the same physical cable, the only way the data will get from one network to another is through a router. So a router is always required to connect multiple networks together, whether they're virtual or physical. So we looked at and identified the different roles of network devices in a local area network. We looked at the advantages and disadvantages of internet connection types. We looked at how to connect a computer to a wired and a wireless network, and some of the basic wireless access point settings.